In number 13, it says the base angle of an isosceles triangle is 43 degrees. If you remember, the vocabulary base angle is a word for the two equal angles in an isosceles triangle. So if one is 43, then the other is also 43. It says, what is a measure of an exterior angle to the vertex angle of this triangle? Well, there's two ways to do it. I think most students do this. First of all, can I find the vertex angle? And the answer is yes. I have two angles in the triangle. So we take 43 and 43, add them up, we get 86. And then 180, because that's the sum of the angles in a triangle, minus 86 gives you 94. So the vertex angle is 94. Now we want an exterior angle to the vertex angle. So what we do, exterior means to extend one of the sides. And we really want this angle here. So if you notice, it is supplementary to the vertex angle. So we can make a rainbow. And then we can do, since we have two angles that form a line together, we can do 180 minus 94, which gives us 86. So final answer is 86. Now, there's a quick way to do it. These are two of the remote interiors, and you have this exterior that you want to find. So 43 plus 43 is just 86 directly. So you could have also done the problem that way. But I think most of you take the approach that I have written down in black. All right, number 14, it says an isosceles triangle ABC. So I will draw that. It says angle A is congruent to angle C. So right off the bat, we have these eyes, and they're looking at the congruent sides across. So BC and AB get marked with the angry eyebrows. And remember, that means that AB and BC are equal. So they told us AB was 2x minus 4. BC was x plus 8. And AC is 3x minus 13. So we know, first of all, be very clear here, these are sides, not angles. So we can't add all of the sides to get to 180. That doesn't work. That works for only angles. But what does work is that these two sides, A, B, and BC, are equal. So we can make an equation out of their algebraic representations. So we can write 2x minus 4 equals x plus 8. And now if we solve this for x, we'll have an x value. So let's take a look. We subtract x from both sides. We get x minus 4 equals 8. Add 4 to both sides, and x is 12. Now they asked us to find the length of each side of the triangle. So AB is 2x minus 4, and we know x is 12. So 2 times 12 minus 4 is 20. BC is x plus 8, which would be 12 plus 8, which is also 20. Should not be a surprise at all that AB and BC are equal, because we said that before. These two sides were equal because they're across from the equal angles in an isosceles triangle. And then we have AC, which is 3 times 12 minus 13, which is 23. So there are the three sides. These all would classify as a correct answer. All right, number 15 says use the following diagram in the fact that BD bisects angle ABC. So if BD is bisecting angle ABC, what that means is that these two baby angles are equal. So they're each going to get one swoosh. And this is review from Unit 1. It says angle ABC, A to B to C, is 4x plus 10. Which is the large angle, and angle ABD is 3x minus 15, which is the smaller angle. Notice I'm putting the label of the angle in the mouth of the angle. I'm not doing that for angle ABC because it's the largest angle, okay? But I did kind of draw the two swooshes and put the angle measurement there. Now, if we know that angle ABD is 3x minus 15, we put one swoosh on angle DBC, that is equal. So we can also put a 3x minus 15 there. So if you notice, it's that they want us to find the value of angle DBC. So if you notice, the two little black angles make up the big blue angle. So we're going to make an equation now. We can say that 3x minus 15, one black angle, plus the other black angle, adds up to make the big blue angle, 4x plus 10. If you're not sure what I'm saying there, if I took DBC, so I want to highlight, if I took DBC, this angle here, and put it together with ABD, I'm getting the large angle. I'm getting ABC altogether. All right, so now we can combine our like terms. We get 6x minus 30 equals 4x plus 10. Subtracting 4x, we would get 2x minus 30 equals 10. Add 10 to both sides. We get 2x equals 40, or 20. Sorry about that. Okay, yeah, so sorry about that. That's way off base. Let's try again. We have 2x minus 30 equals 10. Add 30 to both sides. So 2x is 40. There we go. See, we all make mistakes. Divided by 2, and x is 20. Now, if x is 20, they're asking for the value of angle DBC. DBC is here. So we need to plug that into 3x minus 15. So measure of angle DBC is equal to 3 times 20 minus 15, which is 45 degrees. Problem 16, and again, please ignore the big line across the page. Angle BCA is 8x minus 15. Now BCA is outside the triangle. So important, it's got to go in the mouth outside the triangle here. Angle DBC is 2x plus 12. That's in the triangle. And angle BDC, BDC, it's 4x plus 9. And we learned one day that in class that the two interior angles far away add up to the exterior. So we're going to set up an equation. We're going to say 2x plus 12 plus 4x plus 9. Those are the two far away interior angles. Add up to be the exterior angle, 8x minus 15. So we get 2x plus 4x is 6x plus 12 plus 9, which is 21, equals 8x minus 15. Subtract 6x from both sides, and we get 21 equals 2x minus 15. Adding 15 to both sides, we get 36 equals 2x. Divide by 2, and x is 18. Again, this is an intermediate answer, not our full answer, not our final answer. They're asking us to find the value of angle BCD, which is right here. So if you notice, it's a linear pair with the exterior angle. So I put a rainbow, and we know those two angles add up to 180. So if I find out the exterior angle by plugging the x value in, I can get that number and subtract from 180, and then we're good to go. So we'll do that. 8 times 18 minus 15. So 8 times 18 is 144. Minus 15, which is 129. So this angle is 129. And so 180 minus 129 will give us our answer, which is 51. And so the final answer is 51 degrees. In number 17, it says in the triangle below, the angle measure of CAD is x squared. Angle ADC is 5x minus 20. And BCA is 2x plus 110. And they want us to find the measure of angle ACD. So same thing as in the last problem. We have the two interiors far away from the exterior. So we have to add those two guys up. And that adds up to 2x plus 110. Now in class, I talked about the fact that x squared is like a celebrity. everybody, all the terms in the equation want to be on that side of the street or that side of the equation. So x squared's on the left, so the 2x needs to move over, and notice I want to put it underneath the 5x when we subtract it, so they're like terms. Like terms line up, and negative 110 underneath the negative 20. So we get x squared plus 3x minus 130 equals 0. And now it's time to do IM factoring. Okay, and you're looking for a pair of numbers that multiplies a negative 130 and adds up to positive 3. And that pair of numbers happens to be plus 13 and minus 10. And that's from Algebra 1. So then, take each factor, set it equal to 0. X equals negative 13, which for algebra purposes is great, but for our purposes, we reject that answer because we're dealing with angle measurements. And here, x is 10. X is 10 is going to be the x value that we need. Now, again, we're asking for the measure of angle ACD, which is here. So similarly to the last problem, we have linear pair here. And so those two angles add up to 180. So we can find the exterior angle BCA by plugging in our value of 10. And 2 times 10 plus 110 is 130. And for our final answer, we do 180 minus 130, and we get 50 degrees. Number 18 says, can a scalene triangle also be classified as isosceles? Well, a scalene triangle, by definition, has all unequal sides. So for example, 5, 6, 7, that would be scalene. Isosceles, by definition, has 2 equal sides. So this is scalene, and this is isosceles. So they don't go together. You can't have a triangle that's both scalene and isosceles. So a triangle cannot be both scalene and isosceles. And you can word this a bunch of different ways, but I'll word it like this, because, I'm abbreviating here, because a scalene triangle has no equal sides, and an isosceles triangle has 2 equal sides. And we'd be good. Number 19 says, can an isosceles triangle also be classified as a right triangle? Explain your answer. And this is true. This was on your quiz, actually. If you had a 90-degree angle here, in a right triangle, you could only have one 90-degree angle. So if it's going to be isosceles, it's the other 2 angles that have to be the same. So if we do 180 minus 90, that's 90, and divide that by 2, we would get 45 and 45. Okay? And there, you have a right angle, so the triangle's a right triangle, and you have 2 equal angles, so it's also an isosceles triangle. So the answer is yes. The base angles, which are the equal angles of the triangle, could be 45 degrees each. And the other angle, or I'll use the word vertex, could be 90 degrees. I'm going to stop the video here, and I'm going to pick up with a new video because YouTube won't allow us to put videos more than 15 minutes. So I'm going to pick up with number 20 in the next video.